What if I told you that the stars are not as far away as they seem? What if humanity could one day travel to distant galaxies, not in generations, but in years or even months? Sounds like science fiction, right? But what if it's not? What if the key to unlocking the cosmos is already within our grasp? Welcome to the story of the warp drive, a revolutionary concept that could change the way we think about space, time, and the very limits of human possibility. For centuries, humans have dreamed of exploring the stars. From the ancient Greeks who mapped the heavens to the Renaissance astronomers who first peered through telescopes, the cosmos has always called to us. But there's a problem: space is big. Really big. Even our closest stellar neighbor, Proxima Centauri, is over 4 light-years away. With current technology, it would take tens of thousands of years to get there. That's where the warp drive comes in. It's not just a faster spaceship, it's a complete reimagining of how we travel through space. Instead of moving through space, what if we could move space itself? What if we could bend the fabric of the universe to bring the stars to us? The idea of a warp drive isn't new. In fact, it was first proposed in a scientifically plausible way by physicist Miguel Alcubierre in 1994. Alcubierre's theory was inspired by none other than Albert Einstein's theory of general relativity, which tells us that space and time are not rigid but can be warped by mass and energy. Alcubierre imagined a spacecraft that could create a warp bubble around itself, compressing space in front of it and expanding space behind it. Inside this bubble, the ship would remain stationary, while the space around it moves faster than the speed of light. The result? Faster than light travel without breaking any of Einstein's rules. But here's the catch: Alcubierre's warp drive requires something called exotic matter, a theoretical substance with negative energy density. This exotic matter would be needed to create the warp bubble and sustain it. The problem is, we've never observed exotic matter in nature, and creating it in a lab is far beyond our current capabilities. So, is the warp drive just a pipe dream? Not necessarily. In recent years, scientists have made significant strides in understanding the physics behind warp drives and exploring ways to make them a reality. For example, researchers like Dr. Harold Sonny White at NASA's Eagle Works laboratory have been working on refining Alcubierre's equations and testing small-scale experiments to see if warp bubbles could be created in a lab. While we're still a long way from building a functional warp drive, the fact that serious scientists are working on this problem is a sign that the impossible might one day become possible. So, why does this matter? Why should we care about a technology that might not even exist for centuries? The answer is simple: the warp drive represents more than just a way to travel faster. It represents hope, a hope that humanity can overcome its limitations and reach for the stars. It's a reminder that the impossible is only impossible until it's not. And who knows? Maybe one day, thanks to the warp drive, we'll be able to visit distant worlds, meet alien civilizations, and explore the universe in ways we can only dream of today. But before we get ahead of ourselves, let's take a closer look at the science behind the warp drive and the challenges we'll need to overcome to make it a reality. To understand the warp drive, we need to dive deeper into the mind-bending physics that makes it possible. At its core, the warp drive is all about manipulating space-time, the four-dimensional fabric that makes up our universe. According to Einstein's theory of general relativity, massive objects like stars and planets warp space-time, creating what we experience as gravity. But what if we could control that warping? What if we could create a localized distortion of space-time to propel a spacecraft? That's the essence of the warp drive. Let's break it down. Imagine space-time as a rubber sheet. If you place a heavy object on the sheet, it creates a depression. Now, if you could somehow compress the sheet in front of an object and stretch it out behind, the object itself wouldn't need to move, it would be carried along by the motion of the sheet. In the context of a warp drive, the object is the spacecraft, and the rubber sheet is space-time. By contracting space-time in front of the ship and expanding it behind, the ship could effectively ride a wave of space-time, traveling faster than light without actually moving through space in the traditional sense. This idea was mathematically formalized by Miguel Alcubierre in his 1994 paper, where he described a warp bubble that could achieve this effect. The bubble would be created by a ring of exotic matter surrounding the spacecraft, generating the necessary distortion of space-time. Inside the bubble, the spacecraft would remain in a region of flat space-time, meaning the crew wouldn't experience the extreme forces that would normally make faster-than-light travel impossible. It's a bit like surfing on a cosmic wave, where the wave does all the work, and you just ride along. But here's where things get tricky. The exotic matter required to create a warp bubble isn't something we've ever seen in nature. Exotic matter has negative energy density, which means it would repel rather than attract. This is the opposite of how normal matter behaves. To make matters worse, the amount of exotic matter needed for a warp drive, according to Alcubierre's original calculations, was astronomical literally. It would require the equivalent of the mass energy of an entire star. For a long time, this seemed like an insurmountable barrier, and the warp drive was relegated to the realm of science fiction. However, recent advancements in theoretical physics have given us reason to hope. In 2012, Dr. Harold Sonny White and his team at NASA's Eagle Works laboratory revisited Alcubierre's equations and made a groundbreaking discovery. They found that by altering the shape of the warp bubble, making it more of a donut shape rather than a flat ring, the energy requirements could be drastically reduced. Instead of needing the mass energy of a star, a warp drive might only need the mass energy of a small spacecraft, like the Voyager probe. This was a game changer. Suddenly, the warp drive went from being a purely theoretical concept to something that might one day be achievable. But the challenges don't end there. Even if we could create a warp bubble, there are still significant hurdles to overcome. For one, we don't yet know how to generate or control exotic matter. Some theories suggest that quantum phenomena, like the Casimir effect, might provide a way to produce small amounts of negative energy, but we're a long way from scaling that up to the levels needed for a warp drive. There's also the question of stability. A warp bubble could theoretically collapse or become unstable, potentially trapping the spacecraft or causing catastrophic effects. And then there's the issue of navigation. How do you steer a warp bubble? How do you avoid colliding with objects in space when you are moving faster than light? These are all questions that scientists are still grappling with. Despite these challenges, the pursuit of the warp drive has sparked a new wave of interest in advanced propulsion technologies. Organizations like NASA, as well as private companies and research institutions, are investing in the study of warp physics and related fields. Some researchers are exploring alternative approaches, such as using gravitational waves or quantum entanglement to manipulate space-time. Others are looking into the possibility of harnessing dark energy, the mysterious force driving the expansion of the universe, to power a warp drive. While these ideas are still in their infancy, they represent the cutting edge of human ingenuity and our relentless drive to explore the unknown. So, where does this leave us? Are we on the brink of a warp drive revolution, or is this just another tantalizing dream? The truth is, we don't know yet. But what we do know is that the pursuit of the impossible has always been at the heart of human progress. From the first steps on the moon to the discovery of the Higgs boson, we've repeatedly pushed the boundaries of what we thought was possible. The warp drive is no different. It's a challenge, a puzzle, and a beacon of hope for a future where the stars are within our reach. Now that we've explored the science behind the warp drive and the challenges we face, let's take a step back and consider the bigger picture. What would it mean for humanity if we could actually build a warp drive? How would it change our understanding of the universe, our place in it, and our future as a species? The implications are nothing short of revolutionary. First and foremost, a functional warp drive would open up the cosmos in ways we can barely imagine. Right now, even our most ambitious space missions are limited by the vast distances between stars. The Voyager 1 probe, launched in 1977, has traveled farther than any human-made object in history, and it's only just now entering interstellar space. At its current speed, it would take tens of thousands of years to reach the nearest star. But with a warp drive, that journey could be reduced to a matter of years, or even months. Suddenly, the galaxy would become our playground. We could visit neighboring star systems, explore exoplanets, and search for signs of extraterrestrial life. The dream of becoming an interstellar species would no longer be a distant fantasy, it would be within our grasp. But the impact of a warp drive wouldn't just be limited to space exploration. It would also revolutionize our understanding of physics and the nature of reality. The development of a warp drive would require us to solve some of the deepest mysteries of the universe, from the nature of dark energy to the behavior of space-time at quantum scales. In the process, we might discover entirely new laws of physics or uncover phenomena that we can't even imagine today. The pursuit of the warp drive could lead to breakthroughs in fields like quantum mechanics, general relativity, and even cosmology, reshaping our understanding of the universe and our place within it. There's also the question of what we might find out there. The universe is vast and ancient, with billions of galaxies, each containing billions of stars and planets. Statistically speaking, it's almost certain that life exists elsewhere in the cosmos. But without the ability to travel between stars, we may never know for sure. A warp drive would give us the tools to search for extraterrestrial life, not just in our own galaxy but in others as well. Imagine the possibilities. We could discover alien civilizations, learn from their technologies, and even form interstellar alliances. The cultural and scientific exchange that would result could propel humanity to new heights of knowledge and understanding. Of course, with great power comes great responsibility. The ability to travel faster than light would also raise profound ethical and philosophical questions. How would we handle the discovery of alien life? What rights would extraterrestrial beings have, and how would we ensure peaceful coexistence? And what about the potential for conflict? History has shown that new technologies can be used for both good and ill, and a warp drive would be no exception. We would need to develop international agreements and ethical frameworks to ensure that this technology is used for the benefit of all humanity, not just a privileged few. There's also the question of how a warp drive would affect our sense of time and identity. According to Einstein's theory of relativity, time slows down as you approach the speed of light. This means that a crew traveling on a warp-driven spacecraft might experience time differently than people back on Earth. A journey that takes a few years for the crew could take decades or even centuries for those left behind. This raises fascinating questions about the nature of time, aging, and human relationships. How would we stay connected across such vast distances? How would we preserve our cultural and social ties in a universe where time itself is relative? Despite these challenges, the potential benefits of a warp drive are too great to ignore. It's not just about exploring new worlds or making scientific discoveries, it's about ensuring the survival of our species. Earth is a fragile oasis in a vast and often hostile universe. Sooner or later, we'll face existential threats, whether from asteroid impacts, climate change, or other global catastrophes. A warp drive would give us the ability to spread out among the stars, reducing the risk of extinction and ensuring that humanity endures for generations to come. So, where do we go from here? The road to a warp drive is long and uncertain, but it's a journey worth taking. It's a testament to the power of human curiosity and our unyielding desire to push the boundaries of what's possible. Whether we achieve a warp drive in our lifetime or centuries from now, the pursuit of this dream will inspire generations of scientists, engineers, and dreamers to reach for the stars. As we wrap up this exploration of the warp drive revolution, let's leave you with a thought. The universe is vast, mysterious, and full of wonders waiting to be discovered. The warp drive is more than just a technology, it's a symbol of our potential as a species. It's a reminder that no matter how impossible something seems, we have the power to make it real. So, what do you think? Will humanity one day conquer the stars, or are we destined to remain earthbound? The answer lies in our hands and in the choices we make today. Thanks for joining us on this journey, and don't forget to share your thoughts in the comments below. Until next time, keep dreaming of the impossible. Request to please subscribe this channel for getting more interesting stories like this. Thanks. Imagine a future where the vast emptiness of space is no longer a barrier, where reaching distant stars is as easy as taking a flight across the globe. For centuries, humanity has looked at the night sky with wonder, dreaming of traveling beyond our solar system. But one thing has always stood in the way: distance. The closest star system, Alpha Centauri, is over 4 light-years away. With our current technology, even the fastest spacecraft would take thousands of years to get there. But what if we could bend the very fabric of space itself, making interstellar travel not just possible, but instantaneous? This is where the concept of the warp drive enters the picture, a revolutionary idea that challenges everything we know about physics and space travel. The idea of bending space-time for faster-than-light travel isn't new. It has been a staple of science fiction for decades, from Star Trek's famous warp drive to countless novels and films. But in 1994, something extraordinary happened. A theoretical physicist named Miguel Alcubierre proposed a mathematical model that suggested warp drives might not be just fantasy, they could be possible within the laws of physics. His idea was based on Einstein's general theory of relativity, which describes how space and time can be warped by massive objects like planets, stars, and black holes. Alcubierre's model suggested that instead of violating the cosmic speed limit, the speed of light, a spacecraft could compress space in front of it and expand space behind it, effectively allowing it to surf through space without moving faster than light itself. This was a groundbreaking moment because it provided a framework for what was once purely imaginary. But there was one big problem: energy. To create this space warping effect, Alcubierre's equations indicated that an enormous amount of negative energy would be required, something far beyond anything we could produce with our current technology. Negative energy, often linked to exotic matter, is a concept in physics that remains largely theoretical. Some ideas suggest that the Casimir effect, a phenomenon observed in quantum field theory, might hint at the existence of such energy. The Casimir effect occurs when two unchanged arced metallic plates are placed extremely close together in a vacuum, creating a measurable force between them due to quantum fluctuations. This has led some scientists to believe that harnessing quantum mechanics could provide a way to create negative energy. But even if we could generate it, the amount required for an Alcubierre-style warp drive was calculated to be equivalent to the entire mass energy of the observable universe. Clearly, something needed to change. In the years following Alcubierre's proposal, physicists and researchers have continued refining the idea. One major breakthrough came from Harold Sonny White, a NASA engineer and physicist who suggested that by altering the shape of the warp bubble, making it more of a toroidal or donut shape rather than a perfect sphere, the energy requirements could be dramatically reduced. White's work at NASA's Eagle Works laboratory brought new hope to the possibility of a real warp drive. His experiments focused on trying to detect tiny distortions in space-time, which could be early indicators that manipulating space is within our reach. While results have been inconclusive, they have inspired a new generation of physicists to explore the concept further. Another intriguing approach involves the study of naturally occurring space-time warping phenomena. Scientists have observed that gravity itself bends light around massive celestial bodies, an effect known as gravitational lensing. This has led researchers to speculate that if space-time can naturally curve due to gravity, perhaps there's a way to artificially create and control this curvature for propulsion. Some theories even suggest that certain quantum field effects, like vacuum energy fluctuations, could be harnessed to generate the exotic conditions necessary for a warp bubble. At the heart of all these efforts is a fundamental question: can we control space-time itself? Theoretical physics offers some tantalizing possibilities, but without experimental evidence, we are still in the realm of speculation. Some scientists remain skeptical, pointing out that while the math may work on paper, turning these equations into real technology is another challenge entirely. But history has shown that ideas once considered impossible often become reality with new scientific discoveries. The dream of interstellar travel may seem distant now, but so did the idea of human flight before the Wright brothers took to the skies. If we could unlock the secrets of space-time manipulation, it would revolutionize not just space travel but our understanding of the universe itself. Suddenly, entire galaxies would be within reach. The limitations of time and distance would crumble, opening up possibilities we can scarcely imagine. But the road ahead is long, filled with obstacles that will require breakthroughs in physics, engineering, and energy generation. Could quantum mechanics hold the key? Will future discoveries in dark energy and gravity provide the missing pieces? The search for a real warp drive is one of the most exciting frontiers in modern science, pushing the boundaries of what we believe is possible. One of the biggest challenges in making the warp drive a reality is understanding the nature of space-time itself. While Einstein's general theory of relativity tells us that space and time are interconnected and can be distorted by gravity, controlling these distortions in a practical way remains a mystery. Some physicists believe that if we could manipulate the fundamental fabric of the universe, perhaps using quantum mechanics, we might find a way to create a warp bubble without requiring impossible amounts of energy. This has led scientists to explore the strange and often counterintuitive world of quantum field theory, where particles and energy fluctuate unpredictably even in the vacuum of space. One area of research that has gained attention is the concept of vacuum energy. In quantum mechanics, empty space is not truly empty, it is filled with tiny, fleeting energy fluctuations known as quantum vacuum fluctuations. These fluctuations suggest that space itself is not a passive background but an active and dynamic entity. If there were a way to manipulate vacuum energy on a large scale, it could potentially provide the exotic matter or negative energy needed to create a warp bubble. Some researchers speculate that dark energy, the mysterious force driving the accelerated expansion of the universe, might hold the key to this technology. If we could understand and harness dark energy, it could provide a means of stretching and contracting space on demand. Another exciting avenue of exploration is the link between gravity and quantum mechanics. two fundamental forces that have remained largely incompatible in modern physics. Theories like quantum gravity and string theory attempt to bridge this gap, suggesting that space-time itself may have a deeper, more fundamental structure than we currently understand. If space-time behaves differently at extremely small scales, it's possible that a new understanding of these quantum effects could provide insights into how a warp drive might be constructed. Some researchers have even proposed that microscopic wormholes, tiny tunnels through space-time, could be related to quantum entanglement, hinting at the possibility that manipulating quantum connections might allow us to engineer large-scale distortions in space. Despite these intriguing possibilities, there are still major obstacles to overcome. One of the biggest concerns is stability. Even if a warp bubble could be created, keeping it stable while traveling through space is another challenge entirely. Some theoretical models suggest that the structure of a warp bubble could collapse or destabilize due to unpredictable quantum effects. Others suggest that if a ship inside a warp bubble were to move faster than light, it would be completely cut off from the outside universe, unable to send or receive information. This raises the question of whether warp travel, even if possible, could ever be controlled safely. Another potential issue is the energy release at the end of a warp journey. Some models predict that when a warp bubble collapses, it could release an enormous amount of energy, potentially destroying everything in its vicinity. This so-called warp wake effect could make warp travel extremely dangerous unless a way is found to dissipate or redirect the energy safely. Additionally, recent research suggests that faster-than-light travel might create dangerous feedback loops of radiation, posing another challenge to any practical implementation of the warp drive. While these obstacles are significant, history has shown that scientific breakthroughs often come from unexpected directions. Today's impossible problems might be tomorrow's solved equations. This is why several institutions, including NASA and independent research groups, continue to study warp field mechanics, looking for new insights that could bring us closer to turning science fiction into science reality. Some researchers are even conducting small-scale experiments to test the feasibility of warping space on a microscopic level, using high-energy lasers and electromagnetic fields to observe possible distortions in space-time. Although these experiments are still in their infancy, they represent the first steps toward a future where space travel is no longer bound by the limits of conventional propulsion. If scientists do manage to create a working warp drive, the implications would be enormous. Humanity would no longer be confined to our solar system. We could explore distant stars, colonize new worlds, and perhaps even encounter other intelligent civilizations. The ability to bend space-time would not just be a revolution in transportation, it would fundamentally change our place in the universe. It could redefine our understanding of physics, technology, and even our purpose as a species. The question now is, how close are we to making this dream a reality? Will the next century bring a breakthrough that changes everything? Or will the warp drive remain one of the greatest unsolved mysteries in the history of science? As researchers push the boundaries of our understanding, one thing is certain: our journey into the cosmos has only just begun. If the warp drive becomes a reality, it will mark one of the most profound turning points in human history. For the first time, the vast distances between the stars will no longer be insurmountable barriers but mere navigational challenges. Interstellar exploration, which once seemed confined to the realm of science fiction, could become a routine endeavor. The ability to travel at faster-than-light speeds would allow us to establish colonies on distant exoplanets, expand beyond the limits of our solar system, and even create interstellar civilizations. But with such an immense leap in technology comes a host of ethical, philosophical, and existential questions that humanity must confront. One of the biggest concerns is how interstellar travel would reshape human society. Throughout history, technological revolutions such as the advent of the steam engine, electricity, and the internet have dramatically changed how people live, work, and interact. A functioning warp drive would introduce changes on an even grander scale. Borders would become meaningless as entire planets became accessible. Trade and communication would extend across star systems, and the economy could evolve into something entirely new. Resources that are rare on Earth, such as helium-3 or exotic minerals found on asteroids, could become common, leading to shifts in global power dynamics. Would humanity unite in the face of this incredible advancement, or would new conflicts emerge as different factions seek to control warp technology? Then, there is the question of extraterrestrial civilizations. If we achieve faster-than-light travel, it is almost inevitable that we will encounter other intelligent beings. The Fermi paradox, which questions why we haven't found evidence of alien life despite the vast number of potentially habitable planets, might finally be answered. But how would first contact unfold? Would we be welcomed into a galactic community, or would we find ourselves in conflict with civilizations that see us as a threat? The possibility of encountering advanced species raises significant concerns about how we should approach these interactions. Should humanity send emissaries of peace, or should we prepare for potential hostilities? Science fiction often portrays alien encounters in both utopian and dystopian ways, but the reality could be far more complex. Another intriguing question is how warp travel might affect our perception of time and space. If a spacecraft can bend the fabric of reality to travel between distant stars in moments, how will this affect our understanding of causality? Could paradoxes arise if information or matter moves faster than light? Some physicists believe that certain types of faster-than-light travel could allow for time loops, where events could influence their own past. Would this mean that a warp-capable civilization could manipulate time itself, or would the laws of physics impose natural safeguards against such paradoxes? These are questions that science has yet to fully answer, but they will become critical if warp technology becomes feasible. Beyond the scientific and philosophical implications, there is the deeper existential question: what does it mean for humanity to leave Earth behind? Throughout history, our home planet has been the center of our existence, the place where all human life and culture have originated. If we become a spacefaring civilization capable of traveling across galaxies, our identity as a species will fundamentally change. Earth will no longer be our only home, and future generations may grow up on distant worlds, under alien skies. Will they still see themselves as human in the same way we do today? Will new cultural and societal divisions emerge between those who remain on Earth and those who explore the stars? Some futurists believe that the warp drive could lead to the next stage of human evolution, not just in a biological sense, but in terms of intelligence and consciousness. Exposure to new environments, alien ecosystems, and possibly other forms of life could force humanity to adapt in ways we cannot yet predict. Advances in artificial intelligence, cybernetics, and genetic engineering may accelerate this transformation, making future explorers vastly different from their Earth-bound ancestors. Could the warp drive be the first step toward a post-human era, where our species merges with technology and transcends its biological limitations? The journey toward a real warp drive is still in its infancy, and many scientific and engineering hurdles remain. But what was once considered pure fantasy is now being explored in serious academic research. From Alcubierre's theoretical framework to NASA's experimental studies, the dream of bending space-time is no longer just a dream, it is a possibility, however distant. As research continues, new discoveries in quantum physics, energy manipulation, and space-time dynamics could bring us closer to unlocking the secrets of interstellar travel. If we do succeed, the universe will open before us like never before. We will no longer be a civilization bound to a single planet or even a single star system. The cosmos, with all its mysteries and wonders, will become our new frontier. The only question left is, when that moment comes, will we be ready to take the leap? Please subscribe for more interesting videos like this. Thanks.